So here we are at chapter 9. This is a short chapter, but we're carrying on this talk about rational expressions. In the previous chapter, we simplified rational expressions, and now for chapter 9, we are going to multiply and divide them. And pretty much the same rule applies as it did in 7 and 8 and now 9. If you didn't pick up on the factoring, or you didn't do too well or comprehend those chapters 3, 4, and 5, then you're probably not going to do that well with these chapters involving the rational expressions, because there is a lot of factoring involved, and that's probably where most of the work is as far as multiplying and dividing rational expressions. So best thing you could do if you're having trouble with these chapters is probably go back to 3, 4, and 5 and spend a little more time with them. Now at the top of the page of chapter 9, first page, we have here the multiplication of two fractions, and this is just in general. Our first fraction is a over b, and then we have times c over d. And this should look familiar if you took Intro to Algebra. This is the template that we used for multiplying fractions, and what we see over here on the right is that we simply just multiply the two numerators, a times c, and that gives us the numerator of our product, and then the denominators multiply b times d, and that gives us the denominator of our product. Now this goes hand in hand with what we're going to do with polynomials, or rational expressions. So in this case, p of x, q of x, r of x, and s of x, they're all polynomials. And so if we have a rational expression here, okay, rational expression 1, and then here we have another rational expression 2 with multiplication in the middle. Alright, well, we pretty much do the same thing we did with the numbers. The two top polynomials multiply to give us our numerator of the product, and then our two bottom polynomials, they multiply to give us the denominator of the product. So pretty much the same procedure for either real numbers or polynomials, or rational expressions, you could say. Now when we multiplied numbers, typically one thing we did was we would cross simplify. And so with the numbers, this is sort of what it would look like. The 12 and the 18 share a common factor, 6. And so 12 divided by 6 makes this a 2. 18 divided by 6 replaces this denominator with a 3. So we can cross simplify, we can reduce these numbers. And now for 25 and 10, we can divide these two and reduce them to 25 divided by 5 is 5, and then 10 divided by 5 is 2. So it makes the numbers that we're dealing with smaller. And over here on the right, we see that our numerator is now 2 times 2 instead of a 12 times 10, and we end up getting a 4. And then in the denominator we have a 5 times 3, a 15. Alright, so the point is we could simplify first, multiply, and then we would have our final fraction in lowest terms. Now with the rational expressions, workbook gave us a note. It said it is highly recommended to simplify first, which makes sense. If you do not simplify, as here on the top, we have 2 terms, and on the top of this rational expression, we have 3 terms. Okay. Now if we multiply this without simplifying, then over to the side we're going to end up with 2 times 3, 6 terms that may or may not reduce. They may not be like terms, and that's a lot of multiplication. And then likewise on the bottom you have 3 times 2 terms, another 6 terms in the denominator. So that's just not the way we want to go about it. Again, it all goes back to factoring the numerator and denominator of the rational expression. So here they've written x squared minus 1. It's the difference of squares, and it is written as a x plus 1 times x minus 1. And then for this numerator, x squared plus 4x plus 3, it was factored x plus 3 times the x plus 1. 3 times 1, 3. 3 plus 1 gives us this 4 here. And so they went along and factored the denominators likewise. And what happened was that for at least this first fraction, x plus 1's canceled. And then we can cross cancel. There's an x minus 1 here, and then an x minus 1 at the bottom of the other fraction. Here's our multiplication in the middle, and then you see that this x plus 1 cancels out along with this one over here in the numerator. So in the end, a lot of things cancel out, and what looked to be like a long drawn out problem, or could turn into quite a bit of work, is pretty simple as long as you know how to factor. The numerator becomes a x plus 3 and the denominator a 2. So that brings us to example 1. We simply have to factor all the parts of our rational expressions and then cancel out what's common to the numerators and denominators. X plus 3, that can't be factored. For the other fraction, we write x plus 2, x plus 3. A 2 times the 3 gives us the 6, and then a 2 plus 3 gives us the 5. Alright. The denominator of the second fraction breaks up into a x plus 2 times an x plus 2. Alright, so we can cancel out these two x plus 2's. But now to cancel this other one out on the bottom, we have to find another x plus 2 in the numerator, and there happens to be one right there at the top of the first fraction or rational expression. And then we have an x plus 3 on the bottom and 1 on the top over here in the second rational expression. So a lot of things cancel out again, and we're only left with 2 terms, an x minus 2. Alright, so with everything canceled out that we could, this is the simplest form of example 1. Example 2. A 6x minus 3, we can factor out a 3. That leaves us with a 2x minus 1. And on the bottom we have a 10x. We'll leave it that way. And now at the top of the second rational expression, we can factor out a 5. And we get 4x squared plus 2x plus 1. And this polynomial on the bottom in this denominator here, it is the difference of cubes, and it factors as a 2x minus 1 and a 4x squared plus a 2x and plus a 1. Okay, so at first we were probably thinking, hey, we're going to have to do the AC method and this is going to require another step, but turns out this is probably not factorable, and even if it was, we have another 4x squared plus 2x on the bottom here, so this is going to cancel out anyway. And then we also have a 2x minus 1 in the numerator and the denominator, so that will cancel out. And so I'll just pick up what's left, and this is probably a place where things can go wrong if you weren't careful to pick out everything that's left. We have a 3 here and a 5 there, so on the top of our product we have a 3 times 5 and then a 10x on the bottom. And now for the numbers, 5 will reduce to 5 over 10. 5 divided by 5 is 1. 10 divided by 5 is 2. So the final form of our product will be 3 over 2x. Now, this looks a little clustered, I guess you could say. But if we write it a different way, the way we're used to, this A over B, if you consider this to be fraction 1, and then the C over D to be fraction 2, then you would interpret this situation as a fraction divided by a fraction. So we'll write it this way with the traditional division symbol, and we'll write C over D out to the side. And when dividing fractions, what we do is we switch to multiplication. Okay, and we take the reciprocal of the second fraction, and we do all of this in one step. In other words, we flip the fraction. That's what reciprocal means. And so we don't necessarily divide numbers. We really sort of switch over to multiplication. And we've already learned how to do that on the previous page. And so at this point, we would say our product, or originally our quotient, is going to turn out to be AD divided by BC. And you can see that's pretty much where they took this example. We have the same thing that the workbook does. This may make a little more sense. AD over BC. And so that's the trick. Just to remember that when you're dividing two fractions, you switch to multiplication and you flip the second fraction. The first fraction stays the same, and then you just simply multiply. Okay, so they walk through some examples here. We have 8 over 15 divided by 16 over 45. Let's see what happens. Division turns to multiplication. And we also flip the second fraction, 45 over 16. And then we run through the numbers. 8 and 16, they simplify with an 8. So 8 divided by 8 gives us 1. 16 divided by 8 gives us a 2. And then likewise we can cross simplify the 15 and the 45. They're both divisible by 15, so 15 divided by 15 gives us this 1. 45 divided by 15 gives us that 3. Okay, so now we have a 1 and a 3 on top, 1 and a 2 on the bottom. We multiply them, we get 3 on top, 2 on the bottom. Now, with our rational expressions, the polynomials, we see that the first rational expression stays the same. Division is transformed into multiplication, And now the second rational expression is flipped. We have x squared minus 9, it goes to the bottom, and then x squared minus x minus 2, it goes to the top. Now that we've switched over to multiplication and flipped a fraction, we look at the next step, and you see that we just simply factored all of the numerators and denominators. Negative 3 times 2 is a negative 6. Negative 3 plus a 2 is a negative 1. The difference of squares here factors as x plus 2 and an x minus 2, and so on. So at this point, what we do is we cross things out that are common to both the numerator and denominator, and we're left with an x plus 1 and an x plus 3 as our rational expression. Alright, so example 3. First thing we'll do is we will change our division of two fractions to multiplication. So that we're not tempted to cancel anything out here, we'll just rewrite the entire problem. So our first rational expression stayed the same. We replaced division with multiplication, and now we're going to take the denominator of the second rational expression, put it on top, and take the numerator and write it in the place of the denominator. Now we'll factor the numerators and denominators. 4 is the greatest common factor of 4x minus 20. We divide that out of each term, and we will get an x. 20 divided by 4 is 5, so we have a minus 5. An x squared plus 6x plus 9 is a perfect square trinomial, and it factors as a x plus 3 times another x plus 3. This numerator will factor as an x minus 4, x plus 3. And so just to double check, negative 4 times a 3 is a negative 12, and a negative 4 plus a 3 is a negative 1. And now for the denominator, we have factors of x. Let's see, minus 4 and x minus 5. So negative 4 times a negative 5 is a plus 20, and a negative 4 plus a negative 5 is a negative 9. So the way I factored these polynomials, it checks out, and now we just simply cross out what's common to both numerator and denominator. Canceled out this x minus 4 with this one, and then one of these x plus 3's will cancel out, but there isn't another x plus 3 on the top to cancel that one out. We do, however, have an x minus 5 on both top and bottom, so they'll cancel out, and in the end we are only left with a 4 and an x plus 3 on the bottom. Alright, so our first step, example 4, we keep the first rational expression the same. We change division to multiplication, and we take the reciprocal of the second rational expression. we factor our expressions. This numerator, 4x squared plus 12x, we can use greatest common factor of 4x, and that leaves us with a remainder of x plus 3. Now for the denominator, 2 is common to both, and we can take out an x squared, and that's going to leave us from the 2x to the third with an x, and then a negative 2x squared divided by a 2x squared would just simply be a minus 1. For our second fraction, we can factor out an x from these two terms, and we're left with an x minus 1. And then for 2x plus 4, we can factor out a 2, and we're left with an x plus 2. Alright, so here we have an x minus 1 cancels out. And what I'll do at this point is go ahead and multiply the numerator and the denominator. We have some other things that'll cancel out, but it may be a good idea just to sort of reaccumulate all of our terms. Okay, so on the top here we have a 4x and an x, so that would multiply to give us a 4x squared, and then we have this binomial here, and so we'll write it off to the side, x plus 3. Now for the denominators, we have a 2x squared times a 2, and 2 times 2 is 4, and so we have an x squared that we put to the side of it, and then we're left with a binomial of x plus 2 in the denominator. So once we recollect all of our terms, what's left, we see that this 4x squared cancels on both the top and the bottom. So our final answer, rational expression in simplest form, is a x plus 3 divided by x plus 2. Okay, example 5. I usually don't like working with fraction wrapped up inside of another fraction and so on, so we can simply just take the way this is written and write it the way we've seen in the previous examples by just looking at this part on the top as the first fraction or rational expression, 2x to the third on the top and 8 minus 6x on the bottom. The large division bar here should be replaced with a division symbol, and then we skip over to the right and we simply write the denominator, 8x over a 16 minus 9x squared. So what we'll do first is we'll take this and we'll convert it to a multiplication problem. First rational expression stays the same. Second one, we use the reciprocal. Now that we're dealing with multiplication, we'll factor the numerators and denominators. We can't really factor 8x, so I'll go ahead and write it in the place of the denominator in the second fraction. And notice that this doesn't have a greatest common factor, but 16 is a 4 squared, and 9x squared is also a perfect square that we can write as a 3x squared. Okay, so we take our square roots 4 and 3x, and we construct our factors, 4 and 4. 4 times 4 gives us the 16, and then 3x and 3x multiplied will give us our 9x squared back, but then we need to make one plus and the other one minus. so that it ends up being a minus 9x squared. Alright, we see that this 4 minus 3x cancels out, and now we'll cancel these 2's out, and we'll sort of recollect our terms. We have only an x to the third power left on the top, and then an 8x on the bottom. And for the x's, we'll apply the quotient rule, and we'll keep the x to the third on the top because it has the larger exponent, and we will subtract the 1 from the x on the bottom from the 3, and in the end we end up with an x squared over an 8. So that brings us to our last example of the chapter. Following the same procedure as we have in all of the other examples, we will first switch over to multiplication, and we'll take the reciprocal of the second rational expression, and now that we're dealing with multiplication, we will factor all of the parts of our expressions. Okay, now this is a difference of cubes, and so that kinda gets a little long and drawn out, so I'm gonna extend this first fraction bar a little bit more, because we end up with a binomial and a trinomial, so 2 and then 3 terms. Now the cube roots of x to the third power is x, and then the cube root of 8 is 2. So our first factor is going to be an x and a 2, and then we just copy the minus sign since we were dealing with the difference of cubes. The first term of the trinomial is the first cube root squared. We have a 2 squared here, which I'm going to erase and replace with a 4. And now our middle term of the trinomial would be a 2x. Third sign's always a plus. The 2x minus 4 will factor as a 2 times an x minus 2. Here on the numerator of the second fraction we have a difference of squares, and so that will factor as an x and an x, and then for the negative 4 a minus 2 and a plus 2. Let's see, finally our last denominator from these 3 terms, we can factor out a single x. We get an x squared plus a 2x plus a 4. So our trinomial from this first numerator is going to cancel out. Our x minus 2, we could cancel it out with that one, and we have another x minus 2 over here, but they can only cancel out in pairs, so we don't have another one in the denominator that we can use to cancel out either one of these, x minus 2 or x plus 2, so we have to keep them. Alright, now here are the factors that we have left on the top, and then we have a 2x left in the denominator. And so I would be happy with this if you had if you were taking the test and you wrote this as your answer for show your work problems. But if you were doing a multiple choice and you didn't happen to see x minus 2 times x plus 2 in the numerator, then you should know to look for their product, x minus 2 or x squared minus 4 over 2x. So either one of these could be written in the numerator, or I'm sorry, could be written in a multiple choice problem. And that concludes chapter 9. If you have any questions about any of the examples that we worked, feel free to see me in my office hours. Otherwise, thanks for watching.